In Essential Task 110, we are going to identify the various principles that influence memory at each of the stages identified in Essential Task 17: encoding, storage, and retrieval. Because Essential Task 110 is rather long, I've divided it up into Essential Task 110A and 110B. Occasionally during the year, you are going to encounter a topic which I believe requires more than one piece of paper, and as a result, I've identified a logical breaking point that divides the material up. However, in order to connect 110A and 110B, instead of just calling it 110A and 111, I use A and B just to ensure that you know that these topics are very much still connected to each other. So I recommend for 110A a horizontal piece of paper. 110A is everything that you see underneath this letter A. It's going to be the 5 boxes under encoding, and then the 4 boxes here under storage. The logical break between 110A and then subsequently 110B is right here. So where you see the B and the arrow down, that will not be done until a separate video. This video is exclusively going to talk about the encoding and storage columns under 110A. However, these are technically all under the big umbrella of the various influences and principles that influence memory at the 3 stages we previously identified. In Essential Task 110A, we are specifically going to be talking about the encoding process and the storage process. Much of this concept map involves demonstrations. As alluded to in the class agenda, we are going to be synchronizing the demos so that regardless of whether or not you are at home or in person, you can still hear and see the demonstrations. So as we progress through, as we are about to do starting with encoding, we are going to reference demos that in theory you've either just experienced or experienced previously in class. We are going to start under the short-term memory region of the encoding column. If you recall, when we first talked about memory in Essential Task 17, we identified the capacity of short-term memory, which was 5 to 9 bits of information. And we did a series of quick demonstrations that indicated that. Students typically had success memorizing 4 numbers, 6 numbers, but things got quite difficult at 8, and certainly when we tried 12. There is, however, a way to manipulate exactly what is classified as a bit of information. If you go back and look at the definition of short-term memory, it specifically says 5 to 9 bits of information. And the reason it says that is that because something like the number 12 is recognized by your brain as a singular number, you can kind of manipulate the raw quantity of numbers that you can keep within your short-term memory by using what's called chunking. So, for example, instead of 121188087, if you were to redo that demo, as we just did, and think to yourself, 1, 2, okay, that's 12, 1, that's 11, 80, 87. And instead of trying to memorize 1, 2, 1, 1, 8, 0, 8, 7, you memorize 12, 11, 80, 87. Because those individual numbers, 12, 11, and so on, are manageable units, bits of information that you're familiar with, you can actually, quote unquote, expand the raw number of information that you can keep within your short-term memory, as long as those are unified and manageable bits. So you're still capped at 5 to 9. That doesn't change. But you could theoretically remember 12 or 14 numbers using this technique. That's what we, in theory, just demonstrated. Perhaps some students, perhaps you, were able to successfully remember 10 numbers using this technique. It is really the only way to manipulate your short-term memory because that 5 to 9 limit is strict. Proceeding onward, we are going to be talking about the other topic under short-term memory, and that is what we call rote rehearsal. This is an incredibly ineffective way to study. When you use rote rehearsal, you essentially just repeat something over and over and then move on to something else and repeat it over and over. This is a very common way of studying something like vocab, and it's incredibly ineffective. Essentially, when you sit there and just repeat a definition over and over, you do a really good job of keeping it in that 20 to 30 second window of your short-term memory. That's basically what you're doing. But when you proceed on to another term and start repeating the definition over and over, all you're really doing is turning it into your short-term memory. And as you transition from vocab word to vocab word, there's a high probability that you experience encoding failure, meaning although you interacted with the material, you never actually stored it away in long-term memory. Rote rehearsal is a great example of an ineffective way of studying, which we will hopefully avoid doing. For example, I imagine you've seen the Statue of Liberty dozens of times throughout your life. However, often students are unsure of whether or not the Statue of Liberty is holding up its right or left hand. What hand is the flame in? Although it's a visual that you've seen dozens of times throughout your life, you've really only interacted with it briefly. It's been there in your short-term memory for 20 to 30 seconds. And because you never had intent to really encode the finer details, that finer detail is simply not in your long-term memory. Proceeding onward under the encoding box, we are going to continue to this location here labeled serial position effect. It's kind of this bridging topic between short-term memory and long-term memory. As we were able to demonstrate, individuals tend to recall items, words, numbers, etc., in a list at the very beginning and at the very end. So if I gave you a list of 20 things, chances are you remember probably the first 5, the bottom 5, and maybe a couple in between. We call this the serial position effect, and it actually does a really good job of illustrating the difference between long and short-term memory. Whenever we did that demo a few moments ago, and we started reading out those words, chances are you were trying to repeat them in your head. So computer and baseball, the first words that you heard me say, most people try and repeat and are really focused on trying to memorize those because everybody wants to do well in the memory tasks. So they're really focused at the beginning. But then we get to the middle of the list and you start to feel overwhelmed because you're overwhelming your short-term memory. Then at the very end, we end off with a couple words. And when I ask you to repeat as many back as possible, because you practice those first words quite a few times, there's actually a reasonable chance that a few of them made it into long-term memory. The middle words, when you started to get overwhelmed in that 20 to 30 second range, 5 to 9 bits of your short-term memory, chances are a lot of that never actually even made it to long-term memory. However, the very end of the list is still within that 20 to 30 second window, so chances are you remember quite a few words from the very end of the list. The ability to remember the beginning of the list, because you rehearsed it and practiced it multiple times, really focused, hoping to do well at the task, and the short-term memory cleaning up those last couple words, illustrates as a whole what we call the serial position effect. As I've alluded to, this demonstration box, not something you have to write down. Students typically will use the small letter D logo, perhaps next to the word serial position effect, to remind them that we did in fact do a demo for this term. Specifically, when you remember the beginning of the list, that's what we call the primacy effect. The very end of the list, the most recent terms, is what we call the recency effect. And as a mnemonic, again, that's what the letter M stands for. When I see the word cereal, I think of the food cereal, and I think about the fact that oftentimes you go to the supermarket with a food list. The serial position effect is very important to connect to the word list. This was actually an FRQ bullet once, and it was important to use the word list somewhere in your definition or your answer, because this is very specifically what happens when you try to memorize words in a list. Just to give you a really quick visual, you tend to do very good at the beginning of a list. You can easily recall because there's a higher chance that you got that transferred and stored away into long-term memory. The middle is when you get a little bit overwhelmed. And then the recency effect is where that short-term memory kicks back in and you remember those last couple words. If you ever were to see this graphed, which is a common type of multiple choice question, you're looking for a U shape. The serial position effect is reflected as a U shape. Moving on, we're going to finish off the encoding boxes and proceed to the levels of processing. We demonstrated the levels of processing when I asked each group of people in class to evaluate the terms differently. I asked students to evaluate the terms based on either shallow or deep processing. Those of you who had to count the number of syllables in a term or count the number of vowels in a term, you were not engaging with the list that I read at a very deep level. You were doing what was called shallow processing. And as a result, students tend to do much worse when engaging in shallow processing during that demo. However, those of you who had to evaluate whether those terms were pleasant tend to remember way, way more words. Why? Because evaluating in the moment, at that point of encoding, if a term is pleasant, requires you to evaluate the meaning of the word, requires you to evaluate if that term has ever related to an experience in your life. It requires you to illustrate what's called deep processing. And when you deeply process a term at the point of encoding, there is a much higher chance that you recall and retrieve that information at a later date. And what's important here is I specifically produced a 30-second gap between the words that I read out loud and the recall phase of that. Meaning, I made sure that nothing about those words were in your short-term memory. For this demo, you had to rely exclusively outside of that 30-second window, which means you relied exclusively on your long-term memory. And as a result, students that deeply processed those words tended to do significantly better on that demonstration. Additionally, anytime a student was able to apply the term to their own experiences, which often happens when you evaluate whether or not a term is pleasant, like the word like Monday, for example. Individuals in class that had to evaluate whether Monday is pleasant probably related it to their own personal experiences. Whenever you can take a term that you're studying and apply it to yourself, you also see an increased recall or retrieval from your long-term memory. We call that the self-reference effect. So, for example, when you're studying a list of vocabulary, if you, more than just repeating the definition over and over, rote rehearsal, that's ineffective. If you can deeply process the words by evaluating whether or not they affect your life, or whether or not they're pleasant, or whether or not they are enjoyable, you are studying and implementing really precise techniques based on the theory of deep processing or levels of processing, or alternatively, the self-reference effect. As we alluded to, we demonstrated that students that had to process each of those words at a deeper level at the point of encoding performed better on the recall memory task. We just finished the encoding portion of the concept map, the 5 boxes all the way to the left. We are now going to proceed to the storage portion of the concept map, which are the 4 remaining boxes that you see. Some topics and issues under storage. Once a bit of information has been stored away, so it actually reached your long-term memory, it's usually useful to continue rehearsing or studying that material again and again. That's what the word rehearsal means, to revisit, sort of study a second time. Doing so eliminates decay. Decay is a word that we use for forgetting. We call this overall process either distributed practice or the spacing effect. The benefit and the enhancement of your memory when you distribute your practice and study over a prolonged period of time instead of all at once. There's been a ton of research that shows that if you chunk your studying bit by bit over the course of the week, you're way more likely to improve your memory, avoid decay, and then have that information easily retrievable from your long-term memory on the day of a test. If you wait for the day before a test, you're way more likely to experience decay, which is going to result in forgetting and obviously a worse grade. So as the year progresses, particularly once we get past the holidays and enter into the 2021 year, we are going to be doing a lot of distributed practice and really trying to harness the spacing effect in order to ensure that we review frequently enough leading up to the AP exam. This is the furthest down this box goes, and then we're going to move to one final column on the right. It is important to exhibit whether it's the spacing effect or distributed practice. They're synonyms of each other. Due to the work of Hermann Ebbinghaus. Ebbinghaus is going to get a contributing psychologist icon, so he's important, but I wouldn't classify him as one of the overwhelmingly important names. What Ebbinghaus found is that you actually forget material pretty quickly. So if you were to graph how much information you forget, you actually lose a large percentage of learned material in the first couple days after you've initially encoded it. So even if you encoded fairly effectively, you were able to pull some information out of long-term memory when you went and did your homework that night, you actually tend to forget quite a bit of that information after the first day. What's really fascinating is that the amount that you forget begins to plateau. So the rate, the pace, how quickly you forget, actually decreases over time, which might sound a little bit weird, but I'll give you an example of this. At this point, it's been a decade plus since I've been in a Spanish class. I have forgotten virtually all of the Spanish that I've ever learned, or most of it. However, in the first couple of years after I stopped taking Spanish, that is when most of my forgetting occurred. At this point in my life, 10 years after my last Spanish class, I don't have any more Spanish to forget. I've already forgotten as much of it as I could. So I lost a ton of my Spanish knowledge and skills very quickly in the months and years after I stopped taking Spanish as a class. Now, 10 years later, I've plateaued. The rate at which I've been forgetting, how fast I've forgotten, is simply stopped. It's plateaued. The overall quantity, so not the rate, the overall amount of Spanish has probably continually increased. I've lost a little bit more Spanish over time, but it happened really quickly at first, and now it is plateaued. We call that the forgetting curve, where you tend to forget a lot very quickly, and then it decreases over time. However, if you can distribute your practice and study progressively as time goes, whether that's the week leading up to an exam or the AP exam or even just Spanish, you can start to eliminate the forgetting curve and make it so that you forget less and less and less. This is one of the pivotal reasons why distributed practice is so beneficial and why cramming the night before an exam might get you by that exam, but in the long run, that information is not going to be in storage for your retrieval necessities on a final exam or, in this class, an AP exam. So we call this the forgetting curve. If this were to be graphed, you'd see a very sharp decline and then a plateauing effect. The final little bits to talk about are under the category of maintaining long-term memory, and then that is where we will end the concept map for today. Throughout the first 10 concept maps, you've seen this letter M a few times. And this is one of the psychology Prezi symbols that we'll use throughout the year. The letter M technically stands for mnemonic device. It's not a physical item. I know the word device can kind of come across as meaning some type of physical item. It's just a term that we use for any memory trick that we implement over the course of the year. Memory tricks are what we call forms of elaborative rehearsal, meaning a more sophisticated way of engaging with material that often requires you to pull from prior knowledge. So, for example, when we use Mr. Cognition as a way of remembering the thinker statue as a representation of the thinking process, that's elaborative rehearsal. We're pulling our past experiences and our knowledge of that statue and using it to remember a different topic. Whenever you implement any mnemonic, whether that's looking at the way a word looks, reminding yourself of an experience that you've had, you're utilizing a really well-refined memory trick, and specifically elaborative rehearsal. Using mnemonics is superior to rote rehearsal. That was what we talked about at the beginning of this essential task, where you merely just repeat information over and over. You are not going to effectively encode information into your long-term memory and storage simply using that type of studying. Mnemonic devices, on the other hand, although sometimes a little bit silly, I will certainly admit that. You will see some silly ones in this class as the year progresses, has been shown to be a far more effective means of memorizing. There are a lot of different mnemonic devices. I particularly like this one. Some people call this the journey method, the method of Loki. With this technique, and we're going to practice it in class, what you do is you associate the information that you're trying to memorize with unique locations. So, for example, you put a vocabulary word or a psychology term in your bedroom and in your bathroom and in your kitchen and in your living room. Or maybe you do it within locations of the school. So you put a vocabulary word in the art room, in the lunch, in the gym, in the auditorium, in my classroom. Or maybe you can even specifically use my classroom. So you envision a vocabulary word at my desk, at your desk, at my podium, at the whiteboard, etc. And you try to connect the term you're memorizing with each of these distinct locations. And what this does is on the day of the test, the quiz, or when I ask you to recite back words for a memory task, you are able to sort of in your head walk through the location. And in each of the distinct locations that you've identified, you're able to, in your mind, envision each of the terms. This technique is incredibly effective, and I know it might seem a little bit silly, but this is the precise technique that many memory champions utilize in order to memorize really incredible things. I'm talking a deck of cards in order in under a minute. I would like you to watch the first 5 minutes or so of the video embedded here on the left. That will be provided to you in Google Classroom as well, so you'll see the link. You will see a memory champion describe and then implement the method of Loki. I've cut it off at 5 minutes, so you don't have to watch him go through the whole deck of cards. You watch him go through a couple cards. But if you were to watch that whole video, I think he goes through it with only one mistake, which is pretty impressive after only less than a minute of looking at the deck in order. But that concludes Essential Task 110A. In our final video of this unit, we will progress to the boxes on the right. So these boxes over here will not be part of the concept map that you just finished. We have completed this concept map now that we have finished the final box under storage.